All right, guys, I'm going to go through this worksheet here with you. It's got all the answers on it already. That way, if you couldn't have worked one of these out on your own, you can kind of look at this video and just find out maybe what went wrong. Number one, we want to find the derivative of this. So we're going to do the power rule. We're going to multiply power times the number in the front. That's 20. And then you take 1 off of the power, which is 4. And you're just going to keep doing that for the other ones. 4 times 8 is 32. Take 1 off the power, it's 3. 3 times 6 is 18. Take 1 off the power. And then the derivative of 7x, we're going to use a constant multiple rule for that. It's just going to be 7. And then the derivative of 5 is 0. So we can just get rid of that. Number 2. For the following equation, evaluate f prime of -1. So that means we're going to take the derivative first, and then we're going to plug in -1. So f prime, using the same steps as the problem above, we do the power rule. The derivative would be this. And then to find f prime of -1, we're just going to plug in -1. So this is going to end up being -20 minus 12 minus 6. Putting all 3 of those together, we end up with -38. Number 3, we want to find the equation of the tangent line. So the first thing we want to do is we want to find our slope, which can be found by doing, well, actually, I'll teach it the same way I taught it before. We need an x value, we need a y value, and we need a slope. Okay. The x value is given. To find the y value, you just plug 1 into your function. So if I plug 1 in up here, I'm going to end up with -3 I end up with -6 there for the y value. To get the slope, we're going to be plugging 1 into the derivative instead. The derivative is -15x to the 4th plus 2x. And then we plug 1 into that. I get -13. So here's my x value, here's my y value, and here's my slope. Now they wrote their answer like this. I taught you guys to write it a little bit differently, but I think that the software will accept it either way. So we'll put the 13 here where the m is. We'll put the 1 for the x value there, and we'll put the 6 for the y value there. Actually, though, it's a -6, right? So there's that. So there's our tangent line. And they chose to write it like this, where they add the 6 to the other side. I don't see any reason to do that, but I'm pretty sure the software would accept either one of those answers. All right, let's go ahead and take a look at number 4. Given this function here, find dy dx, express your answer in simplest form without using negative exponents. So the first thing I'm going to do is I'm going to rewrite that as 1x to the -1. Anytime you have a term in the denominator and you want to apply the power rule, you need to move it up to the top and make the exponent a negative. So I didn't actually take a derivative yet, so that's still equal to y. But now I want to find the derivative, and that's just another way of writing this. So I'll write it this way this time, just because that's what they're using. But we're going to multiply the 1 times the -1. We take 1 off the power, and they said to rewrite it without negative exponents. So I would make the exponent a +2, and I can do that if I put it down in the denominator like that. And there's my final answer. Let's go and take a look at the next one. All right, so number 5, they give me this function here, and they're asking me to find the third derivative. It's the third derivative because there's 3 of those little marks there. So you're just going to do the power rule a whole bunch of times. So let's do f prime, the first derivative. Take your 4 and multiply it times the fraction. Negative 5 over 6 times 4. You can think of that as 4 over 1. That would be negative 20 over 6, which reduces to negative 10 thirds. So negative 10 over 3 x to the, and then we take 1 off of the power, and it's 3. And we're just going to continue that. Same thing here. Multiply the number to the front, take 1 off the power, and so on. Notice that this became negative 3/10 because I multiplied it by a negative 3. So that's the first derivative. Now we'll do the second derivative. I'm going to multiply the 3 times this fraction, which would end up giving me negative 10x to the second power if you take 1 off the power there. Take the derivative of that, that's going to be negative 12x. Take the derivative of that, that's going to be negative, actually it can end up being positive because we're going to do a negative 4 times a negative 3/10. So it's going to be positive 12 over 10 x to the negative 5 now. I think I will go ahead and reduce that before I go any further. We'll go ahead and do the last derivative. We're asking for the third derivative, so this will be the last one I do. That would be negative 20x minus 12, and multiplying that negative 5 to the front is going to leave me with negative 6x to the negative 6, and that's good enough. Let's go ahead and take a look at number 6. Find the derivative. All right, this is an exponential function with a base of e. You could think of this as kind of like a chain rule. We have an inside function up here, and the outside is the e. So when you're doing the derivative of the inside is 5x to the 4th plus 4x cubed. And we're going to multiply that by the derivative of the outside. When you take the derivative of an exponential, though, it just stays the same. I think on the software, they're going to want that to have parentheses, just so you guys know. All right. Let's go ahead and move on to number 7. These ones are pretty much the same thing. You're going to treat it kind of like a chain rule. You have your inside function here. The derivative of that is negative 36x to the 5th minus 35x to the 4th. Then you have the derivative of the outside, but in this case the outside does stay the same, kind of like the last problem did. But we're going to get a little something extra in this case, because anytime your base is not e, you're going to end up with an ln of whatever this number is. And the order doesn't really matter. You'll notice they put their ln in the middle. It doesn't really matter. It's the same thing either way, but there's our derivative. All right, moving along to number 8. All right, another chain rule problem here. We've got the derivative of the inside is 8x plus 6. The derivative of the outside, which is an ln, is 1 over whatever the inside is. And it looks like they didn't simplify it, but when I taught it, I told you guys to put this on the top. You could even reduce this thing a little bit. I see that all of these numbers here can be reduced by 2. But you don't have to do that, I guess, because as I'm looking, they're okay with leaving it just like that. So you can do the same. Let's go ahead and take a look at 9. Find the derivative again. This time it's a log. So very similar. We're going to do the derivative of the inside, which would be 10x. And we're going to multiply that by the derivative of the outside, which is the log. So that's going to be 1 over whatever the inside is. But we're also going to multiply that by ln of whatever this little number is right here. Okay? And once again, you could reduce these two things together. You could put it together as a big fraction. And then 5 goes into 10 twice. X will take away one of the x's on the bottom. And this would be the simplest way to write the answer. But it looks like, once again, they're okay with that. Moving along. All right, so this is a derivative of an arc-trig function. Now, we learned 6 arc-trig functions. You have to have them memorized unless you want to put them down in your notes and use your notes on your exam. But the derivative of arc sine is going to always look like this. 1 over the square root of 1 minus whatever's on the inside squared. Okay, so that's the derivative of an arc sine function. Now they're asking us to find the derivative when x is equal to the square root of 21 over 5. So we're just going to plug that number in there. And let's see what we end up with. So first of all, when you square a square root, it just makes the square root go away. So instead of square root of 21, that's going to be 21. And when you square the 5 on the bottom, that's going to be 25. All right, next we're going to need to get a common denominator here to simplify this a little bit. We have 1 over square root of 25 over 25 minus 21 over 25. Then we can do our subtraction. Oops, my bad. It's 4 over 25. Then we take the square root of that fraction. If you want to take the square root of a fraction, you just square root the top and bottom separately. So the square root of 4 is 2. Square root of 25 is 5. And then when you have a complex fraction like that, I like to just multiply the bottom by the denominator there, which I can do as long as I multiply the top also, and I end up with 5 over 2. Moving on to number 11. They just want us to find a regular old derivative here. So the derivative of 2z to the 5th is 10z to the 4th. And the derivative of this guy, the 4 stays because it's a constant multiple. The derivative of sine is cosine. And that's it. Let's take a look at number 12. Given this function here, we want to find the derivative. Now, in this case, we have two things being multiplied, so we're going to use the product rule. In case you forgot what the product rule is, if you're taking the derivative of two functions that are being multiplied, then it's f times g plus f times g, derivative on the f for this guy, derivative on the g for that guy. Okay? So this is kind of like my f, and this is kind of like my g. So f prime g plus fg prime. All right, so the derivative of the f would be negative 14x to the negative 3 minus 1. And then we put g there. They're probably going to want parentheses, just so you guys know. Then we put f here. And then g prime, the derivative of this guy, goes here. The 9 goes away, and we're left with negative 5x to the negative 2. Now there's some flexibility with how the answers can be written. For instance, these two things can be swapped, or these two things could be swapped, or both. Another thing is you could take this entire set and swap it with this whole set. Okay, so there's a few variations on it. The reason for that is because it doesn't, when it comes to multiplication, like here we're multiplying two things, it doesn't matter what order they're in. Same thing over here. Or when it comes to addition, it doesn't matter what order they're in. So there is some variation, but this little formula will work. So just letting you know, different ways it can be written. All right, let's go ahead and take a look at number 13. They want us to find the derivative of this. Now that's going to be a quotient rule. So the quotient rule works like this. You have a function where you have a low function and a high function. The derivative is low d high minus high d low, draw a line, and square below. So low d high, the derivative of x is 1, minus high d low, draw a line, and square below. Now, you could try typing that in. I'm not sure if the software will accept it. They do ask you to simplify, but it's kind of a relative phrase, like what do they mean, how simplified do they want? But I would say, you know, if you can, go ahead and simplify it more, since they are asking for simplified. So I would distribute the 1, and I would distribute, actually just multiply those, right? That's going to be negative 12x to the 4th. So here we have double negatives, which is a positive, and then you combine the positive 12x to the 4th with the negative 3x to the 4th, and you end up with 1 plus 9x to the 4th over 1 minus 3x to the 4th squared. Notice they put it in a different order on the top. I don't think that would matter. Matter of fact, I know that that wouldn't matter, so not a big deal. So when they say simplify with these ones, I think what they want you to do is to multiply, multiply, subtract. All right, let's move on to number 14. All right, so they're giving me this, and they want me to find the derivative. It's going to be a chain rule. We have an inside function there, and we have an outside function. The derivative of the outside is moving the power to the front and taking 1 off the power. The inside will stay the same for that part. Then we're going to multiply that by the derivative of the inside, which is simply 3. All right, moving along to number 15. All right, so this is a hard one. A lot of work to do here. It looks like it's a chain rule with a quotient rule. So we have an inside function here, and to do that derivative, I would have to do the quotient rule. And then we have an outside function. So we're going to do the derivative of the outside multiplied by the derivative of the inside. So let's see how that turns out. Okay. So for the outside, taking the 5 and multiplying it to the front, and taking 1 off the power, leaving the inside the same, we have this. And then the derivative of the inside there, like I said, is going to require the quotient rule. So it's going to be low d high minus high d low, draw a line, and square below. And there you go. Notice that This is backwards from what they have, but it doesn't matter. Same thing here, because those two things are being multiplied, so the order doesn't matter. Okay. Now what isn't okay is I wouldn't be allowed to switch this chunk with this chunk because there's a minus between there, and with subtraction, order does matter. But within this chunk alone, we could switch those two parenthesis sets around. That would be fine. Let's continue. All right. Got a trig function here with a chain rule. We have an inside function here, and then the rest of it we could just consider that to be an outside function. So the derivative of the outside is -2 cosine, and we'll leave the inside the same for that. The derivative of the inside is 3, and it looks like they went ahead and multiplied these together to get 6. They didn't say simplify, and so I'm thinking that there would be no problem with them accepting this answer. But it's not that hard of a thing to simplify, so why not? All right, moving along. Number 17. Use the chart to find h prime of 5 in simplest form. So h is a composite function, which means we have to do the chain rule. We're going to do the derivative of the inside multiplied by the derivative of the outside. Next, we're going to plug in the number they give us, which is 5. And from there, we're going to use our table. So, g of 5, according to our table, is -12. G prime of 5 is 1. Lastly, f prime of -12 is -10. So we've got -10 times 1, which is -10. Final answer. So take the derivative applying the rules first, then plug in the number to use the table. All right, that looks like that's it for that side. Let's check out number 18. All right. I better zoom out a little bit for this one. I think I'm going to need to see 2 graphs at the same time here. All right. So for this one, they're telling me that h is equal to f times g, and they want me to find h prime of 7. So the first thing I need to do is I need to find h prime, and that's going to be a product rule. So it's going to be f prime g. Actually, let me rewrite that so it's a little clearer. F prime g plus f g prime. Then I'm going to plug in the 7. Now, f of x is a y value on the graph of f. G of x is a y value on the graph of g. F prime of x is a slope on the graph of f. G prime of x is a slope on the graph of g. So, for instance, f prime of 7. This is the slope of f at x equals 7 on the graph. So x equals 7 is right here. So what is the slope of that line? Well, just looking at the rise over 1, it looks like it's going down 1 over 1. So that's a -1 slope. This is the y value of g at x equals 7. So at x equals 7, the y value of g is 5. Here, this is the y value of f at x equals 7. That's right there, and that y value is 1. And then finally we have this, which is the slope of g at x equals 7. So at this point, what's the slope of this line? And once again, it looks like a -1 slope to me. Now, if you guys are a little bit confused on how to do slope, basically all you're going to do is, like if I wanted to find the slope of this line, you're going to pick any 2 points on the line and do a rise and a run. If you go up, it's +1, and if you go to the right, it's plus however many you went over. So this looks like +5, and rise over 1 would be 1/5. Don't forget that if you go down, that's a negative. If you go left, that's also a negative. Going up is a positive, going right is a positive, and it's rise over run, okay? So that's how you can find slope on a graph. Anyway, we're ready to continue calculating this. So -1 times 5 is -5. 1 times -1 is -1. -5 plus -1 is -6. Final answer there. All right, number 19. Okay, so for these problems, they're asking us to find a derivative of a function that's an inverse. Okay, and we have a little formula for that. So if you ever want to find the derivative of an inverse, it's going to look like this. This is an inverse function, and its derivative will always be 1 over f prime of f inverse of x, just something you got to memorize, okay? Now, what they're doing is instead of using the f -1 symbol, though, they're using g. They're saying g is that. So what I'm going to use, I'm going to use this to go ahead and rewrite this sentence a little bit. I'm going to say, okay, f of x is equal to x cubed plus x squared plus 5x. And instead of saying g of -5 equals -1, I'm going to rewrite that as f inverse of -5 equals -1 because g is equal to f inverse. And I like this notation better because it matches my formula. And what we're looking for is g prime of -5, but I don't want to write g prime. I want to write f inverse prime of -5. And that's what I'm looking for. Okay, so I'm going to start by rewriting, and I'm going to get rid of the g and just rewrite it with some f's because that's what my formula uses. Next, we want to remember what an inverse is. If f inverse looks like that, then f will be the reverse. The -1 is in the parentheses, and the -5 is out here. Okay? So from there, I think we're good to go ahead and move on and find our answer. We're looking for f inverse prime of -5. So I'm going to plug in. Oops, didn't write that correctly. Plug in my -5. Now I can tell what f inverse of 5 is. They tell me right here that that's equal to -1. So I've got 1 over f prime of -1. So now I'm going to find out what f prime of -1 is. Well, here's my f. So f prime is 3x squared plus 2x plus 5. And f prime of -1, I can find that by just plugging the numbers in. And I end up getting 3 minus 2 plus 5, which is 6. And so 1 over f prime of -1 is 1 over 6. All right, so what did we do here? I rewrote it with f inverses instead of g's. Then I plugged stuff into my formula, and then I calculated from there. Right? Go ahead and Do one more. Here's another inverse question, but once again, they're using the G notation instead of the F notation. So I want to rewrite this as F inverse prime of 3. And using my formula, which I shared in the last problem, we would have this. Okay, now this one's a little bit trickier because we have to look for this piece a little bit more so. I want to know, what is F inverse of 3? Well, I know that writing this as F instead of F inverse would reverse these things. And so I'm asking myself, what value of X has an F value of 3? Well, here's where F is 3, and the X that goes with that is 8. So what goes in this parentheses here is the 8. So now that I know that F inverse of 3 is 8, I can rewrite this now as F prime of 8. And then once again, using the table, F prime of 8, I'm going to find where X equals 8, and I'm going to find its derivative. It's right there, which is 4. So 1/4 would be my final answer there. All right, and so that's the kind of stuff that y'all can expect to see on our derivative review test. I'll see you guys later. Bye-bye.